Hello. Good evening. Good later evening. It is 11 p.m. where I am, and I am reviewing this was our homework. So now I don't think I can get in trouble for posting it online because it's already been turned in. Let me see here. All right. So give me just 1 second. We're just gonna copy our problems to a new document. All right. Make it a little bigger. Okay. Let me see. Oh, you know what? Chat rate? Who's chatting? I see no chat. Okay. Maybe I'll make it bigger. This program is kind of weird. Kind of wonky. Oh, okay. Well, never mind. Chat rate is 0. Fine. Okay. Well, good to know. I'm just glad I'm not keeping anybody waiting. Back to the math. Here we go. Our first problem is okay. So, first thing we're going to do is plug in, but we are not going to plug in on the paper. We are not going to write it down because I don't know. That's just the preference of my current professor. So x is approaching. Let's see. Okay, so x is approaching 0 of sine x over x. So you plug in a 0 wherever you see an x. So sine of 0 is going to be equal to 0, and that is going to be over 0. So it's going to be 0 over 0. Which is indeterminate. So pretty much all of these problems are going to be indeterminate limits. So it's either going to be 0 over 0, or infinity over infinity, or 0 to the infinity, or infinity to the 0, or something along those lines. So let's see how quick I can get through these problems right now. So we know we're going to have to do more work, but thankfully we are already in the proper form. to take L'Hopital. So as x approaches 0, sine x derivative is going to become cosine of x. And then x is going to become 1 because L'Hopital's rule says this is f of x, this is g of x. When you have it in this quotient form, which I forget the actual name for it, but then you're able to do L'Hopital's rule, which just entails finding the derivative of this function and separately finding the derivative of this function. So that's what we have done. Derivative of sine is cosine, derivative of x is 1. So now that we have done L'Hopital's rule, we can go ahead and plug in for one final time, and we're going to have cosine of 0, which is equal to 1 over 1, which is 1. Perfect. Okay. On to the next one. I think I'm just going to write it. So it's infinity e to the x over x to the n. Okay, so, and this problem wants to find the limit when n is greater than 0. But, I mean, I guess, no, n doesn't have to be greater than 0. So n has to be greater than or equal to 0. So, we have the form that we want. It's a division problem, right? So that's how we want to do L'Hopital's rule. But our next step, I shouldn't have said but, and our next step is to take the derivative of e to the x, which is e to the x, and the derivative of x to the n, which is just x to the n minus 1. So basically, the gist of this problem is that on top, it's approaching infinity, right? So e to the infinity is equal to infinity, and on the bottom, we have infinity to any power greater than or equal to 0. So doing L'Hopital's rule, each time we do it, the power is going to decrease once, and we're going to have to do it until there's no power at all, and there's only an x and a potential coefficient, and then the x would go away, and you would be left with a constant value. So the whole point of this is that this is going to end up being just a number. Like, say, I don't know, 7x to the 5th. So you're going to have to keep doing L'Hopital's rule, which means keep getting the derivative of this number until there's not an x, because as long as you have an x, this is going to go to infinity, and it's going to be infinity over infinity, which is going to be indeterminate. Yes. Anyways, I guess I should show you the derivative of this would be like, um, so geez, 280, 280. So in this case, if it was e to the x to over 7x to the fifth, you would do L'Hopital, and e to the x is always going to stay e to the x. So it's always going to be infinity on top, no matter what. And it's always going to be infinity on bottom, also until you get rid of this x. And then it becomes 840. And even though 840 seems like a kind of a large number, I guess, 840 in the scheme of what infinity is, I mean, is nothing. So this one answer is going to be infinity, which is going to be does not exist. Anyways, now that I've made a mess, oh, that was the problem. Mm, I don't know. I'm just going to write DNE. We worked through it. On to the next one. Okay. The limit of 1 minus cosine of x over x squared. Okay, so we're already in our form, so we can just go ahead and do L'Hopital. When you take the derivative of 1 minus cosine, 1 is just a constant, so it becomes 0. And cosine, negative cosine, becomes positive sine of x. And then finding our derivative of x squared, that will turn into 2x, but as you can see, we're approaching 0. So anytime there's an x still in the denominator, it means we're going to still have to do L'Hopital's rule again. So going from sine to its derivative, we're going to end up with cosine of x. And the derivative of 2x is going to be 2. So now we have gotten our variable out of the denominator, which means we can plug in 0 for x. So the cosine of 0 is equal to 1 over 2. The answer is 1/2. On to the next one. Ln of 1 plus x over x. Okay, so ln of 1 plus x is ln of 1, which is 0, over 0, which is indeterminate. So we can do L'Hopital because we're already in our division form. The derivative of ln of 1 plus x is going to be 1 over 1 plus x times 1, because ln of u is equal to u prime over u. So u is 1 plus x in this case. So the top becomes 1 over 1 plus x. The 1 doesn't really need to be there, but I just wanted to illustrate that it exists. Over 1. Go ahead and rewrite the limit. And now we're probably good to plug in again. So we're going to have 1 over 1 plus 0, which is going to be 1 over 1 over 1, which is going to equal 1, which is going to be our answer. Okay, next one. X squared over e to the x. Okay, so we've already got it in our nice form. If we plug it in, it's going to be infinity over infinity. So we're going to do L'Hopital. So rewriting our limit and taking the derivative of top, we end up with 2x over e to the x. As you can see, our e to the x is never going to be anything besides e to the x. So our goal at this point is to get rid of the x in the numerator. So taking L'Hopital again, we're going to end up with 2 over e to the x. Plugging in, we're going to get 2 over infinity, which is going to be 0. Okay. X times ln of x. Okay. So we start by plugging in, and we're going to get 0 times ln of 0, which is 0 times 1. Apparently that's indeterminate because 0 times anything is supposed to be 0, and 1 times anything is supposed to be, well, no, that's not true. Okay, 0 times anything is supposed to be 0. So we're going to say that's indeterminate, and let's go ahead and do, we can't do L'Hopitals because we don't have division going on. But if you look, it's not super difficult to play a trick on the equation and express it as the ln of x over 1 plus x, which is technically the same thing because you do key change flip on this problem, and it would become x over 1. So that's why you can do that. So now we take L'Hopital. Okay. ln of x becomes 1 over x. 1 over x becomes negative 1 over x squared. We plug in 1 plus a very, 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 very small positive number. I mean 1 over a very, 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 very infinitely condensing number, decimal number, which is going to be equal to infinity over, well, that's, you just can't do 1 over 0. So that's indeterminate as well. So, oh, what am I thinking? No, you can still do manipulations on this one. It's not simplified. So simplifying it will help. As I said earlier, you can do key, change, flip. So that's what you're got going on, which means we can get rid of that x, and we get rid of that x, and then we're left with the limit of x. No, wait. Yeah, no, okay. Yeah, I think it's just the limit of x. Okay. Something doesn't feel right about that. Mm, mm, yeah, that's what I got. And I checked it, and it was right. Okay. How about that? Okay. On to the next one. We have got 1 plus 1 over x to the x. So a pivotal formula to memorize is b to the a is equal to e to the a natural log of b. So in this expression, this is going to be b, this is going to be a. So now that we've used our log rule, in order to exponentiate and get the x down out of the exponent and bring it down to the front, now we're doing L'Hopital's. So we're gonna get it in the quotient form. But this is product form. So we have e to that, and now we can do L'Hopital on this expression, which is going to give us 1 over 1 plus 1 over x times negative 1 over x squared over the derivative of negative 1 over x squared is, or I mean the derivative of 1 over x is negative 1 over x squared. So these are going to cancel, and we're going to be left with e to the 1 over 1 plus 1 over x. And then if we plug in now, x becomes infinity, so 1 over infinity is 0. So e to the 1 is equal to e. Okay, on to the next one. X to the x. Okay, so this problem is the same as our last problem. We're going to incorporate that e. So we have the same thing. We have the b to the a. So we are going to rewrite our expression using the natural log properties. So we're going to have e to the x ln of x. And again, we are working on getting our expression into quotient form so that we can do L'Hopitals on it. So I think we have e to the x. It's times negative, yeah. E to the negative 0 positive. So I guess we're just going to call that e to the 0, which is going to be 1. On to the next one. Sec x, tan x. Maybe it's just sec x times tan x. No, it's minus. Okay. Okay. So what we can do here is we can start by rewriting these functions as sine and cosine. And now we can rewrite this as one function, or one fraction, rather. Now we can do L'Hopital. Okay. So cosine of pi over 2. So pi over 2 is right here. This is cosine and sine. So cosine of x is of pi over 2 is 0 over 1, which is not going to work. So we can do L'Hopital one more time. And then we're going to get positive sine x on top and negative cosine x on bottom. And then if we plug in, oh geez, so sine of x was 1. Should actually have been this one, I think. Let's check. Huh. It was 0. Okay, let's see what number we're on. Number 10. Okay, I'm gonna do this one. Oh, there's someone viewing. Hi. Hi, viewer. Sorry, I'm being super boring. I'm just working through these. Oh, it's you. Hey, what's up? Sorry. Let me zoom out. Cool. I'm doing really good. Thank you so much for asking. Okay. Now I can see you. I am doing really good. I'm really working through these at a pretty quick pace, which is good. Now, if only this was the only thing I needed to know, I'd be in great shape. Okay, so I just finished this one. So I'm going to do this one. E to the 2x minus 1 over x. E to the 2x minus 1 over x. Is that right? E to the 2x minus 1 over x. Oh, I see, I see. I was close. But I'm glad I checked because that would have messed up the whole problem. Yeah. How are you doing today? How's the weather? Okay. Oh no. I'm sorry to hear that. Cold weather is no fun. Well, it's probably like 90 right now. Let me see. 86. Kinda spicy, but it's okay. I much prefer it to the alternate. Okay. Now I am going to calculate the limit of e to the 2x minus 1 over x when x is approaching 0. So first thing we do is plug in 0 every time we see an x. So e to the 0 is actually equal to 1, minus 1 is going to be equal to 0 over 0. 0 over 0 is indeterminate. Since we have this in a quotient, it's, e to the 2x minus 1 divided by x. Since we have that, it's already in the form we need it to do the L'Hopital rule. So now ooh, nice. Okay. Um, so taking the derivative, doing L'Hopital's rule, we're going to take the derivative of this, and then we're going to take the derivative of this. So the derivative of e to the 2x is going to be e to the 2x times 2, because e to the x derivative is always itself, plus if there's a coefficient in here, you also have to times that because you have to take the derivative of this expression up here. So we've got e to the 2x times 2 on top. I didn't forget the 1. The 1 just disappears because it's a constant. And on bottom, our x will just become a 1, which this is good news because since we don't have a variable on the bottom anymore, this means we're not going to have to do the L'Hopital rule anymore. We can just plug in. So e to the 2x is e to the 0, which is going to be 1, times 2 over 1, which is going to be equal to 2. Fire sounds nice, though. I remember when I lived in Nebraska going to bonfires out in the country a lot. Have you ever heard of Nebraska before? X over X. Okay, so on our next problem, let me make sure I got the limit right. No, I didn't get it right. Okay. Glad I checked. So plugging in, we have the ln of infinity, which is infinity over infinity, which is an indeterminate, and therefore we need to use the Hospital's rule again. So we take the derivative of ln of x, which just becomes 1 over x times 1 over 1. And now we can already plug in because there's no variable on the bottom anymore. So 1 over infinity is going to be a very, very, very small number. It's going to be approaching 0. So, oh, hmm, maybe I didn't. 0 over 1. Oh, yeah, I guess it would be. Yeah, okay, I was right. So 0 times 1 over 1 is just going to be 0. I hope I'm not super, super, super boring, but I probably am. It is nice to feel like I'm kind of getting it now. A lot better than I did last semester. Let's see here. We are doing 12. So, oh shit. Okay. X squared minus 1 over ln of x. Okay. So starting, we plug things in. X to 0, x squared. 1 squared is 1 minus 1 is equal to 0. 0 over the ln of 1 is also equal to 0. So 0 over 0 is indeterminate. And we are going to use the Hospital's rule because we have our nice quotient. So once again, we are taking the derivative of our top function and then also taking the derivative of our bottom function. And as you can see, we're still not going to have any luck. Well, no, just kidding. I forgot the limit was 1. The x is approaching 1. It's not approaching 0. So, by this logic, we can just plug it in. 2 times 1 is 2 over 1. So 2 is the answer. I can't believe I'm almost done with this assignment. Okay, so we're going to infinity, and it's x times sine of 1 over x. And we are going to infinity to the moon. Aw, thank you. I got a lot of material left to get good at, but if I can get as good as I am at this, then I think I'll be okay. Okay. So, first thing we do is plug in infinity everywhere we see an x. So it's going to be infinity times sine of 1 over infinity, which is the sine of 0, which the sine of 0 is 0. So it's infinity times 0, which is indeterminate because infinity times anything is supposed to be infinity, and 0 times anything is supposed to be 0. So it can't be. So we gotta do shit. We gotta work on it. We gotta. Oops. Okay. Now we don't have the form we want, right? We want a quotient. We want something with a division. So this one's pretty easy. We're gonna rewrite it as sine of 1 over x divided by 1 over x. Because if you were to do this problem, you would do key change flip, and this would become x over 1. So it'd be sine of 1 over x times x, which is what that is. Now, we still won't have luck plugging this one in because 1 over infinity is going to become 0, and sine of 0 is also 0, so still indeterminate, but that's okay. Oh, well, we never did the L'Hopital's rule. Well, no shit. Sorry, I'm so silly. I didn't even ever do L'Hopital's rule. I just rewrote the problem in the correct form. Okay. Hence why I never changed colors. So now let's do L'Hopital's rule. The derivative for sine of 1 over x is going to be cosine of 1 over x times negative 1 over x squared. And then on the bottom, we're just going to have the derivative of 1 over x is negative 1 over x squared. So therefore, those two are going to cross out. And now we can rewrite our limits as cosine of 1 over x. Now plugging in, oh, I don't know how I got a 0. This is supposed to be infinity. That's what that means. So cosine of 1 over infinity means cosine of 0. Cosine of 0 means 1. Okay. Next one. Okay, so we're doing sine of 2x over sine of 3x. And our x is approaching 0. So sine of 0 is 0. So 2 times 0 is still 0. 3 times 0 is still 0. So sine of 0 is 0 over sine of 0 is 0. So 0 over 0 is indeterminate. So we need to do L'Hopital's rule. And we are in our form. So derivative of sine of 2x is going to become 2 times the cosine of 2x, and sine of 3x is going to become 3 times the sine of 3x. Oh yeah, I guess we don't have to rewrite it. So we don't have to rewrite it because we can just plug it in. So cosine of 2 times 0 is cosine of 0. Oh wait, yeah, cosine of 0, which is 1 times 2. So that's going to be 2, and then sine of, oh darn it, I messed up. This isn't sine, this is cos. So cosine of 0 is 1 times 3, which gives us 3. Moving on. Let's see where the infinity goes. That's okay. I don't know. I just hope that maybe I can teach somebody something because it is really fascinating stuff, you know? Okay. So we're going to infinity this time. We're going to infinity. Gosh, I feel like I just did this one. Okay. X plus 1 over x to the x. And it's going to infinity. X plus 1 over x to the x. X plus 1 over x to the x. And we're going to infinity. Okay, good. So for starters, we plug in infinity. Infinity plus 1 is infinity. Over infinity to the infinity power is definitely infinity. Actually, it's infinity to the infinity, which is the indeterminate form. And our functions are as follows. Um, we'll call this A. No, just kidding. We call this B. We call this A. So when you have this situation, I think it's pretty much just when something's raised to like the x power instead of a number, you can then rewrite the limit as e to the a times ln of b. And then from here, we still don't have the form we want, but we have this power pulled down in front. So it's just being multiplied instead of being an exponent. So anyways, we still want to get this in the quotient form. So we have to do another little manipulation. Oops. We are going to change this into e to the ln of x plus 1 over 1. Or wait, x plus 1 over x. Okay. So now that we have it in a quotient form, like we want it, we can do L'Hopital's rule. Yeah, I should probably go a little slower. I'm sorry. Um, okay. I mean, I guess maybe it would like help to understand the I don't know, maybe you've done calculus before, but it's like just like the concept of it. Like what a limit is let's see here. If we have so like I guess this is our function. And if you're trying to find the limit when x is approaching 2, you're trying to find the closest values on each side of 2 that you can reach without actually hitting 2. So, like, if you take the limit of 2 minus, you're going to find where, let's see. So the limit here would be 2 because y is at 2. So the limit for 2 on the left side would be 2, but the limit for 2 on the right side would also be 2, and this is why there would be I don't know. Anyways, I don't know. Now I'm starting to confuse myself. Um, yeah, but that's what a limit is we're not actually like we plug in the actual value at the end, but until we get to the very final step where we plug in the number for x, we're finding approximations, I guess, is how you would say it. Um, okay, anyways, this is total gobbledygook. Let me erase my gobbledygook. Back to our L'Hopital rule. So we have e to the, okay, the derivative of ln to the, or ln of x plus 1 over x would become 1 over, Jesus, x plus 1 over x, which then in turn we flip over and it would become x over x plus 1. And then that's going to be over the derivative of 1 over x, which is negative 1 over x squared. So again, we can flip this over, and then we'll have x, well, we'll actually have negative x squared on the top. Or maybe not. Maybe we don't need to. No, I think we do. Okay. So let me try to rewrite this and simplify. Okay, so this is going to become a negative. Uh, it is a lot of solving. I feel like I did something wrong. Okay. I see here. Might be getting late. think that was the one. Am I just making it more difficult? Okay, I think I'm looking at it wrong. Okay, let's see here. All right, so I didn't find this derivative correctly. So the formula to find the derivative of ln of u, I don't know which side you write that on. Maybe that side. So that's the derivative of ln of u is going to be u's derivative over u. So u is going to be this expression. So the ln of x plus 1 over x is equal to, well, we know it's going to be x plus 1 over x on the bottom. And let's see, u prime x plus 1 over x. See, the thing that is hard to see about this, the thing that I'm having hard seeing about this is because this is equal to x over x plus 1 over x. So then you have to rewrite this as 1 over, or I mean 1 plus 1 over x. And then finding the derivative of this, our 1 disappears because it's just a constant. And our 1 over x is a derivative we come to know because it's pretty frequent, at least in this class. And so the derivative of that is equal to negative 1 over x squared. Oh, no, no, no. I did this wrong. That's the antiderivative. Gosh. So confusing. Okay. Let me u times u prime. Negative 1 over x squared. Okay. Perfect. So let's go back to here. This is going to be negative 1 over x squared. And then the derivative of that is going to be equal to negative 1 over x squared. And so those two are going to cancel. And we are going to be left with e to the x over x plus 1, which that gives us infinity on the bottom. Oh, wait. Okay, well, I guess that means we have to do the L'Hopital again. Fantastic. Lots and lots of solving. So, taking the derivative again, we have e to the 1 over 1, which becomes e to the 1, which becomes e. Now let me see if I got that right. Yep, okay. How funny. Okay. Oh wait, was that the one? Yeah, that was the one. Jeez. What time is it? Oh, Jesus, it's midnight. Let me see, how many did I get through though? Okay, well, I just did 15 in an hour. That's not too bad, right? Oh my gosh, my back. I hope you've got your fire going. I hope you're nice and toasty, warm. Thank you, thank you, thank you. That means the world. Maybe that means tomorrow I can go on and study my next section. Integration by parts. Yep, I think so. But these last five on this assignment that I didn't get to. Oh, good. I'm glad to hear it. The last five on this assignment I didn't get to are kind of doozies. That's what I hate about these problems. There's just always one little trick that you have to know. Just one little trick. Anyways, yeah, it is. It's just all about practice, which luckily this is the only class I'm in right now because it's the summer semester, and so I can devote pretty much every second to it. And I can do live streams and do it. Thank you. But honestly, it's made me really kind of open my mind to the idea of maybe double majoring or changing my major to math or something. I don't know. I don't know. I really do. I guess maybe I shouldn't change away from computer science. Maybe computers are good to be in, but I really do like math. And yeah, I think it would be cool to go on to the next courses like Calculus 3 and differential equations and I don't know. I don't know what the other ones are called. But it'd be cool, you know? I don't know. I just feel like it'd be a good thing to do. Why not? YOLO. Exactly. And I don't know. Well, okay, I guess I shouldn't say I don't know. I've done a lot of application problems when it comes to calculus, but I'm still not very good at them. Yeah, exactly. And if I get good enough at math, I can tutor other people at it and I can make money. What a beautiful thing. Well, I think I might go to bed. I'm kind of tired. But thank you so much again for everything. You're amazing. Thank you, thank you, thank you. And um maybe I'll see you tomorrow night or tomorrow. Good night. Bye bye.